always thinking about you, not doing well. Don't know.
Hello everyone. Today we are going to continue our discussion regarding the basic methods for making economic studies. And today we are going to discuss the annual worth method for this AW. So proceeding with our next slide, we have this simple introduction for this annual worth method, in which this annual worth method is essentially identical to the assumption in this present worth method. And this method is also known by other titles like this equivalent annual worth, the equivalent annual cost, the annual equivalent, and the equivalent uniform annual cost. Okay, and we have this alternative selected by this annual worth method will always be the same as that selected by the present worth method, and all other alternative evaluation methods, provided they are performed correctly. And another one is, as additional application of this annual worth method or analysis, treated here is the life cycle cost or the LCC analysis. But in this lecture, we are only considering this annual worth method, and maybe in our next lecture video, in our future discussion, we will go into this life cycle cost analysis. And the annual worth value is the economic equivalent of this present worth and future worth values. Actually, this present worth values is from the present worth method in evaluating the proposal or alternative, and this future worth value is actually from using the future worth method in evaluating also the same project or a project proposal at the interest rate I for n years. Okay, so all three can be easily determined from each other by the relation as presented in our next slide. So they are interconnected. This annual worth denoted by this AW, which is equal now to this PW, referring now to the present worth value, times this designation of your A given P at I% in n years, and which is also equal now to this FW, referring now to the future worth value, times this designation of A given F at I% in n years. Okay, so you may be confused what is this A given P and this A given F. So basically, before proceeding to the next slide, so we have to review a little bit of this A given P. So this one is derived from our case number 1, in which we are using the PAPA, and our P is just simply equal now to A times this P given A I% and n years. So that is why we call our case number 1 as PAPA, because of this PA. Okay, and in which this is just equivalent to A times the quantity here, so 1 plus I, then raised to the n minus 1 all over 1 plus I, then we have here raised to the n times this I. Okay, so from here we can actually get this A given P. So we can have this A over P, which is just equivalent to A given P, which is equal now to this. So our numerator will be this one, 1 plus I, then raised to the n times I, all over this 1 plus I, raised to the n minus 1. 1 plus I, and then this is raised to the n minus 1. Okay, so this A over P, which is equivalent to this A given P here, this one. So this designation is just simply equal now to this 1 plus I raised to the n times I all over 1 plus I raised to the n minus 1, because this is derived originally from this formula, no? This papa, where p is equal to a times the quantity 1 plus I raised to the n minus 1 all over 1 plus I raised to the n times I. Okay, so for this future work here with regards to a given f, so this is case number 2, no? From this formula, no? Fafa. So f equal to a times this f given a, then we have this I%, and then n years. So case number 2 is Fafa, because this is f, a, if a, so Fafa, and which is also equivalent now to this a, and then we are going to multiply this one with 1 plus I, then raised to the n minus 1 all over I, no? And from this we can actually get this a over f, no? Or a given f, where our a given f is just simply equal now to this I, no? Over this 1 plus I, then we have here raised to the n minus 1. Okay, so your FW times this designation, which is equal now to this one, no? This is comma I, because this is a function of your I, and n because this is a function of your n. Same also for the present work, no? I and n, because this is a function of our I and n here, no? So let us try to remember this one, no? Because we will use this one later, and that would be it, no, for this relationship of your annual worth equal now to this term here for this PW times this designation, and which is equal now to the FW times this designation. And take note that the n in the factors is the number of years for equal service comparison, and this is the LCM, or the stated study period, of the present worth value or the future worth value in our PW or FW analysis. Okay, so proceeding now with our next slide. So when all cash flows estimates are converted to an annual worth value, this value applies for every year of the life cycle and for each additional life cycle. Take note, no? Converted to this annual worth value, so this value applies for every year of the life cycle. So you will better understand this life cycle, no, later in our problem, and for each additional life cycle, meaning each additional life cycle, if we are considering different lives alternatives, so probably you can have an additional life cycle, no, because your proposal maybe is your proposals are having different lives, no, so that is why you may opt to this additional life cycle, no, later, no, in our problem. And take note of this important assumption that the annual worth method offers a prime computational and interpretation advantage, because this annual worth value needs to be calculated for only one life cycle, no? So in our previous discussions using the present worth method and the future worth method, we are considering, no, the many life cycles, no, especially if we are dealing with different life alternatives, no? So in this method, this annual worth method, you only need to consider only one life cycle, because the other life cycle is just the same as the first life cycle, no? So as the other until the end life cycle. Okay, so the annual worth value determined over one life cycle is the annual worth value for all future life cycles. So that is why it is not necessary to use the LCM of lives to satisfy the equal service requirement. So therefore, you only need to use one, no? Only one life cycle, and that would be it, no, in getting this annual worth value using this annual worth method. And these are the assumptions then. The services provided are needed for at least the LCM of the lives of the alternatives. Second, the selected alternative will be repeated for succeeding life cycles in exactly the same manner as for the first life cycle. This is true, no, because your first life cycle is just the same as the second, as the third, as the fourth, and as the end life cycle, no, because they are just repeated, no, especially if you are going to consider a different lives alternatives. And all cash flows will have the same estimated values in every life cycle. So this is also true because your other life cycle is the same as the first life cycle. So probably they have the same estimated values, no, for every life cycle. So to better understand, no, the annual worth method, so we may proceed directly now to this sample problem number 1. Okay. So we have here actually this sample problem, no, is also the same problem, no, if you can still remember, if you are going to use, no, the present worth method, and if you are going to use the future worth method until this annual worth method, no, I'm using the same problem, no, but there are a lot other problems there, but in this lecture today we are just going to concentrate in this specific problem, no, so that we can have a better and a clear understanding of what is the relationship of this annual worth method with regards to the present worth method, in which we will obtain our present worth value, and the future worth method, in which we obtain our future worth value. So according now to the introduction, no, as you can see that they are interrelated, no, by this formula. So that is why in our sample problem I will show you, no, the calculation using the calculated, no, the calculated present worth value, and then using again the calculated future worth value, and then we also calculate, no, using this annual worth method, the annual worth value of a certain proposal or project, and then we are going to compare, no, are they the same, no, you may ask, are they the same, no, if we are going to consider the annual value using the annual worth method, and then if we are going to consider the annual value using the calculated present worth, no, value, and the annual worth, no, value considering the calculated future worth using the future worth method, the question is, are they the same, no? So that is the most important thing, no, that you will learn from this lecture video. You will know and you can answer, no, later after the discussion if their annual worth values are the same, no, using the annual worth method and using the PW values and the FW values obtained from the present worth method and future worth method. So let's do it now. Okay. So the National Home Builders Incorporated plans to purchase new cut and finish equipment to manufacturers offered the estimates below. So for vendor A and vendor B, we have their corresponding first cost, the annual maintenance and operation. They have their salvage value and life, no, respectively. So take note that this negative sign is referring now to the cash outflow, no, meaning in the cash flow diagram this is going downward, no, because this is a cash outflow, and for the positive value, especially the salvage value, this is positive since this is considered as a cash inflow, no, or as a revenue. So in the cash flow diagram it is going upward. So as you can see, no, they have different life, no, for vendor A 6 years, for the vendor B 9 years. So probably in our previous lecture videos considering present worth and future worth method, we get their LCM. So their LCM, no, is 18 years. And the question here is determine which vendor should be selected on the basis of annual worth comparison if the rate of interest I is 15% per year. Okay, so proceeding now with this problem, we first consider the vendor A, and I'm going to show you, no, the calculation of this annual worth value using the calculated, no, PW, in getting this equivalent uniform annual worth, no. this is referring, no, this equivalent uniform annual worth is referring now to the annual worth value AW for this vendor A. So this is now the cash flow diagram of the said, no, vendor A, in which originally, no, the life of vendor A is 6 years. So this is only until this one, no. Okay, 1, 2, 3 until 6 years. So we have the first cost of negative 15,000, so indicated by this negative arrow here going downward. The annual maintenance and operation, so we will term this one as the ammo, which is 3,500. So this is negative, so that is why it is pointing downward. And this vendor A, no, with the salvage value of 1,000, no, positive, meaning cash inflow, and it is pointing upward. Okay. As you can see in this one, you may ask, why is it that we have another cycle here and until this? Because as what I've said, no, they have different life, no. So we take their LCM, no. Kindly review and watch the video, no, on using the present worth method and the future worth method, no, on how we arrive this LCM of 18 and how we arrive to this cash flow diagram. But basically, for vendor A, the specific life is 6, but because our LCM is 18, so we have to extend another life cycle, no, another 6 years. So here, okay, so that is why another 6 years. So if you sum up the 6 and 6, so 12, until such that you add another 6 years, it reaches 18 years because our LCM is 18 years. So you are done, no, of your LCM. So that is why it is only until the third cycle. So take note that in our first cycle, in the second cycle, our first cost is the same, no, 15,000. Our ammo is the same also, which is 3,500 here, and our salvage value is the same also as 1,000 as in the first cycle. So as for the third cycle, no, the same 15,000 here as the first cost, the same ammo here of 3,500, and the same salvage value here of 1,000. Okay, so if we are going to draw, no, the specifics of these life cycles, so we have here, no, in this right side of your screen, this is our life cycle 1, considering those mentions, no, from this cash flow diagram in figure 1, and for the life cycle 2, referring now to this one here. Okay, and for the third life cycle, referring to this one. So they have the same first cost, no, here, they have the same ammo here, okay, and they have the same salvage value here. Okay, so that is why if we are going to use the annual worth method, you only need to consider only one life cycle, no. There's no need for us to consider all life cycles. How about if we reach, no, until 20 life cycles, no? So it takes you a long calculation for that, but according to this annual worth method, you only need to consider one life cycle because they are just the same on the next life cycle until the end life cycle. Okay, so now we are going to consider we are going to consider this equivalent uniform annual worth using this PW. Okay, so we have now a calculation, no, for this one based on this present worth. Okay, so our PW, this one, present worth value, referring to this one, is this 45,037 pesos, no. Our I is simply 15%, no, it is given in the problem. And since we are going to get the equivalent uniform annual worth, so we need to consider, no, our N is just equal now to 18 years, no, because we need to consider the equivalent uniform annual worth considering this life cycles, no, the 3 life cycles here. Okay, so from this one, we have, no, this P is equal now to A. Okay, why we need to use this formula, no? In the first place, why? 1 plus I raised now to the n minus 1 all over 1 plus I raised to the n times this I. So you may ask, no, why is it that we are going to use this formula? Because we are dealing, no, with this present worth value. So that is why we need to consider this formula for P, okay, present or the principal value, okay. So substituting now the given values, so we have here P, no, we have here P, which is equal now to 45,037 pesos, okay. Our N is 18 and our I is 15%, okay. So since we are going to consider the equivalent annual worth, so we are only after to this A here, in which if we are going to get the value of our A, this is just equal now to this P times this 1 plus I raised to the n times I all over this 1 plus I raised to the n minus 1, okay. So we have here this value. So P times 1 plus I raised to the n times this I all over this 1 plus I raised to the n minus 1, okay. So this would be now our value of A, in which our A is just referring now to this annual worth value, okay. So using this AW here, which is our annual worth value, which is also equal now to this A, so we can substitute now the values of our P, which is 45,037 pesos times 1.15 raised now to the, our N is 18, okay, times our I of 0.15, okay, all over 1.15 raised now to the 18 minus 1, okay. So our AW, the annual worth value, is just simply equal now to how much? 7,350, okay. This is just equal now to this 7,350. So this would be it, no, for the value of our annual worth using this calculated PW value of this vendor A, which is equal now to 45,037 pesos, okay. So now we are going to determine, no, this equivalent annual, no, worth of this vendor A using the life cycle. So from this one, we have life cycle 1, 2, 3. So we need to determine the equivalent annual, no, annual worth using this annual worth method, in which this is also referring now to this figure 3 in the screen, no. So this life cycle 1, life cycle 2, and life cycle 3 is just equal now to this cash flow diagram in figure 3 using the annual worth method, no, in calculating this AW, which is the annual worth value. So as you can see, this is our annual worth value from the first year until the 18 years, which is the equivalent, no, of these 3 life cycles here, no. So how we do it? So the equivalent uniform annual worth for the vendor A using the life cycle, no, this one. So we only need to use one life cycle here, because this one life cycle is just the same as the other life cycle, no. So proceeding. So we have this annual worth value equal now to. So first, before we put anything here, just an overview, no, of those terms here. If we are going to consider this amount here, okay? If we are going to consider this one, take note that this is at year 0, meaning this is our principal, no, or the present worth. So how you will get the annual worth, no, using this value. So again, from the formula, no, of your papa, which is P, we need to use this papa, no, which is A, which is equal now to A times this quantity, 1 plus I raised now to the n minus 1 all over 1 plus I raised to the n times I. So you need to use this formula because this one is referring now to the principal amount or present value. So that is why you need to use this case number 1, which we use the word papa, which is equivalent to this P is equal to A times this quantity here. Okay. So question is, you are not directly using this amount here, but you need to determine the equivalent annuity here, no? The equivalent annual amount here, no? Using this principal. So that is why your P here is just equal to the P here, and you have the given N, which is 6 years, the I also, which is 15%, and you need to consider, no, this annuity, which is referring now to the annual worth value of this 15,000 here. So this is the annual worth value you are going to put it here, okay, in this equation later, no, for this 15,000 pesos, okay. So if you're going to calculate this one, so probably this would be annual worth is equal now to this P times this one, okay, P times 1 plus I raised to the n times I all over this term here, okay, 1 plus I raised now to the n minus 1, okay. So you are going to put this one here, okay. So I think we need to put this one right away, okay. So this would be, since this is going downward, so this is negative, no, negative of this quantity, okay. So excuse me, no, so this is negative of this quantity, okay. This is P times 1 plus I raised now to the n times I all over 1 plus I raised to the n, then this is minus 1, okay. So how about for our next term, okay? Our next term is this one, okay, this ammo, no, this ammo here from year 1 until year 6, okay. So this is going downward, no, so this is minus, okay. Since this is already an annual, no, an annual amount, no, from year 1 until year 6, so you can put directly here, no, this 3,000 minus 3,500, okay. So we are done with this one and with this ammo. So lastly is this salvage value, okay. So we are going to consider this salvage value, okay, this 1,000. Okay. So how we will calculate the annual worth here? So as you can see from this cash flow diagram, this amount is our present worth. That is why we are going to consider this case number 1 Papa, in which we determine our P. This is a future worth here in our cash flow diagram. So therefore we will consider the second case, which is FAFA. Okay, in which from this FAFA you need to use this F equal now to annuity times the quantity 1 plus I raised now to the n minus 1 all over your I. Okay, so we are only after now to this A, since this is the annual or annuity. So how to get the value of your A? Okay, how to get the value of this one? So again, our A is just equal now to this annual worth for this amount of 1,000, which is equal now to F times I over this 1 plus I raised to the n minus 1. Okay, so probably this is F I over 1 plus I raised now to the n minus 1. So we can put it here. So the sign is positive because this is a cash inflow, meaning it goes up from the cash flow diagram. So that is why this is plus this Fi, okay, over this 1 plus I raised now to the n minus 1. Okay, so this is now our equation or formula in getting the annual worth value, considering only one life cycle here. Okay, so I hope this is clear, that this is just an annuity, or this A here, if you're going to use this formula for the present worth, and this one is just the annuity or the annual value if you are going to use the formula of your future worth. Okay, so proceeding. So we will just have to substitute the values here. So our annual worth value AW is just equal now to the negative of, okay, so here we have 15,000. Okay, so we are just going to put 15k referring to 15,000, and then we have here 1.15 raised now to, our n here is 6 because we are only considering the one cycle, so until 6 years. Okay, so this is 6, and then times your I of 0.15. Okay, and then all over 1.15 raised now to the 6 minus 1. Okay, and this is minus 3,500, and this is plus. Okay, so this is also equal to, our F is this 1,000. Okay, so 1k, we will just put 1k times your 0.15 all over 1.15 raised now to the 6 minus 1. Okay, so getting the respective values of the three terms. So we have here this negative 3,964 minus this 35 here, 3,500, and we have here for this one is 114. So we can say that our AW is, the annual worth value is just equal now to 7,350 pesos. So we have here negative 7,350 pesos. Okay, so this would be our annual worth value using the life cycle, just only one life cycle if we are using the annual worth method. Okay, so now we are going to proceed. We are done with the calculation of the annual worth value using the calculated present worth in our previous slide. And in this slide we are using the annual worth method in calculating the annual value using this life cycle. So we still arrive at the same value of this 7,350. So let's proceed to the next slide if we are going to consider the calculated future worth value using the future worth method from our previous lectures. Okay, so we have here the third using the FW value in getting the equivalent uniform annual worth for vendor B. So you have now this cash flow diagram in our lecture, in our previous lecture, in which we calculate the future worth value of your vendor A, which is equivalent now to this 557,346. Okay, so again we are going to use this value in calculating the equivalent uniform annual worth AW. Okay, so we are done with this one. So our I is 15 and our N is, we consider our N we will consider again N is equal now to 18 years, and then our I is still 15%. Okay, so we have this FW value so again from case number 2 from FAFA, in which we will get our F is equal now to A times this 1 plus I raised to the N minus 1 minus 1 all over I. Okay, so we are only after now to this to this A which is our AW. So our AW then is just equal now to Fi F times I over this 1 plus I raised now to the N minus 1, which is then equal now to our F is this 557, and then we have this 346, and then our I is 0.15, and then our denominator is 1.15 raised now to the 18. We are using 18 because we are considering the whole until this FW of this amount, so minus 1. Okay, so after that one we get now the value of our annual worth, which is just equal now to this 7,350. Okay, so still we have the same annual worth value using the calculated future worth value in this case. So you may wonder using the present worth, why is it that we have positive value of our 7,350, and using this calculated future worth value we have again positive 7,350, while using the second one here, the second one in our using the life cycle. Why is it that we have the negative sign? We are having the negative sign there because we are considering the whole equation, the whole equation of the whole cash flow. So that is why we arrive at the same we have arrived to that negative value. But here, using the calculated present worth value and this future worth value, we are only comparing the annual worth the annual worth value using the formula the given formula for the P for case 1 and for the formula of F for the case 2. So we are not into the negative sign because we are only after to these numerical values if they are the same with those values or the value calculated from the annual worth method of this proposal for vendor A. Okay, so do not be confused with this, because if you are going to consider the formula for the present worth using case number 1 and the formula for the future worth using case number 2, do not be confused, because we are only after in comparing the numerical values without considering the sign, because that sign is just good for the annual worth method only. That is just good for the annual worth method. But if you are using the future worth method, so you can still use the whole equation and you can still arrive at a negative value of your future worth. And if you're using the present worth, you can still arrive at a certain value of your future worth. So in this case, since we are using the formula, so we are only after now for this numerical value. Okay, so proceeding now. So we are going to consider now the vendor B. So the same process if we are going to consider the annual worth using the PW calculated for the vendor B, so we can go directly to the calculation. Okay, so in our present worth, here we have this annual worth value equal now to, so again we're going to use the amount of, so maybe prior to proceeding this one it's better that we will have this cash flow diagram. Let us have this cash flow diagram for better understanding of calculating the annual worth value using the calculated present worth value. Okay, so we have here this cash flow diagram. Okay, so for vendor B, the calculated present worth value is 41,383, and we are going to determine now the equivalent annual worth of this one using this value. Okay, so again we have here A is just equal now to okay, so we have P times 1 plus I raised to the n times I. Okay, all over 1 plus I raised to the n minus 1. Okay, so substituting now the value in which our A is just equal now to our annual worth, so we have here this amount of 41,383 times 1.15, and we are going to raise this one to 18 since we are considering the whole okay, so 18 times your I of 0.15. okay, all over this 1.15. okay, 1.15 raised now to the 18 minus 1. Okay, so our annual worth is just simply equal now to this amount of 6,753 pesos. Okay. So we are going to compare this annual worth value, no, using this calculated PW in using the life cycle and the future worth amount, no, which is calculated. So take note of this value, 6,753. Again, we do not consider the sign convention here since we are using formula, no, we are using a formula. Okay. So proceeding now to the calculation of the equivalent uniform annual worth for vendor B using the cycle, no, the life cycle here. So in this case, we need to concentrate only to this a single life cycle. Okay. So we are going to calculate the annual worth value, which is equal now to, again, no, for this life cycle we only need to consider one, so this is negative 18, so this is minus, no, so the same formula we use, no, in the vendor A, so we go directly now to the substitution. Okay, so this is probably now equal to 18,000, so we will just denote this one as K times this 1.15. okay, raised now to, our n is 9 because we are only considering, no, this 9 years. Okay, so this is times 0.15. okay, all over this 1.15 raised now to the 9 minus 1, and then next is we have, so we are done with this one, no? So next is we go with this value of ammo. Okay, so this is downward, so that's why this is minus, so 3,100. okay, and then our third one is this 2,000 salvage value, so this is plus because this is going upward, no, so again we go now directly to the substitution, no, so this would be 2K times this 0.15 all over 1.15 raised now to the 9 minus 1. So proceeding with this calculation, we will arrive with the values of this 3,772 minus 3,100, and we have here plus 119. okay, so we will expect, no, a negative value here because we are considering the whole, no, the whole cash flow, no, so we have here the value of your negative 6,753 pesos. Okay, so this would be now our annual worth value, no, using this life cycle, no, so still the same, no, from the previous slide, 6,753, but they have a different sign here because we are considering, no, the whole cash flow, no. Okay, so minus 6,753. okay, so proceeding now to our next one, we proceed to using the FW and getting the equivalent uniform annual worth for vendor B. So we have now this cash flow, no, and this is our calculated future worth value, no, in our previous lecture, which is 512,137 pesos. Okay, so going directly now to the calculation of your annuity, no, for a future worth. So we have, no, here from this F is equal now to A, and then we have here 1 plus n, 1 plus I rather, raised to the n minus 1 all over I. So from here you can get now the value of your A, which is now our annual worth value, and which is then equal now to Fi all over this 1 plus I raised now to the n, no, minus 1. So we will use this annual worth value, no, here, which is it then equal now to, so from here 512,000, so 512,137 times our I of 0.15, okay, all over this 1 plus I, no, 1.15 raised now to the 18 minus 1. Again, no, we are considering, no, the whole 18 years because we are only using the future worth, no, the calculated future worth, so until 18 years here, okay. So our annual worth value is just simply equal now to 6,753 pesos, okay. So they have the same, no, numerical values, and this would be it, no, for this one. And we can now evaluate, no, we can now evaluate the two vendors, okay. So proceeding, no, with the evaluation. So our annual worth of vendor A is just equal now to the negative 7,350, and for our vendor B is just equal to the negative of 6,753. So based on our criteria is we need to determine, no, the less negative, no, and the more positive. But in this case we have now the negative value, so we need to consider the less negative. So in this case the less negative is this annual worth value of vendor B, which is 6,753, okay. So therefore the vendor B selected, since the annual worth value which cost is the less negative, that is it has the numerically largest annual worth value than the vendor A, okay. So that would be it, no, for this day regarding this method. And again, no, thank you very much for watching, and these are my references. And before we end, no, so don't forget to subscribe, no, to my YouTube channel for more videos in the future discussing any related subjects, no, regarding the civil engineering field or even in any other engineering field. So thank you, and God bless us all, and keep safe everyone.